All right, welcome to our weekly live broadcast. My name is Johannes and I'm a trainer with deep dives with developer analytics and machine learning background. And with me, I've got Mikko.
Hi there.
We could again kind of just do the quick intro into weather. It's cold over here right now. It's like 14 degrees centigrade.
That's nothing. It's -10 here in Helsinki, Finland. Beautiful sunny weather, lots of snow, but nice and clear sky.
I'm already considering taking a coat. I don't have one, or I only use it abroad, right?
That's ridiculous.
All right, and then we kind of went into the bin of topics for the show and picked out DevOps. Now in this show, the idea is to talk about DevOps on a fairly high level for people that might just have heard about it, might not kind of see the full picture. And then most likely we will be going deeper into different subtopics in future episodes. And, I guess it's fair to say that this is probably our most, or the topic that we're giving most instruction on, like DevOps or roughly related stuff. And so
there's a reason for that as well. It's important topic.
Well, is it because we're so good in it?
It's because DevOps is needed nowadays. It's essential.
Okay. So just a little bit about the history. I've picked the Wikipedia page here, and it kind of goes back to the 80s and 90s with regards to combining software development methodologies with deployment and operations. But actually, do you remember that in the late 90s, early 2000s, we kind of did DevOps type of stuff, but we named it something different?
I remember all kinds of things from the early days, but I'm not sure what you're referring to.
For
Waterfall
example,
or something else?
No, for example, XP.
Oh, yeah,
extreme programming.
Extreme program. Yeah. For some reason, I'm thinking about rational rows here.
Yeah, that was the design.
Cool.
So the rational unified process, RUP,
RUP
was used to bring together the design and implementation phases, kind of similarly as what we're doing with development and operations here. So in that way, I like for me personally, like as a developer and people who think about how to develop, this is a longer journey, right? We've always been on the verge of trying out new stuff, and now we just call it DevOps, right? And DevOps, what is cool, what I like about DevOps is that DevOps is not one thing. It's not like XP, which was basically one book that was written back in the days, or it's not rational unified process, which is a process by a single company, but rather is that this kind of fairly loose collection of philosophies and methodologies. And there is no like DevOps Incorporated that tells you that this is DevOps and this thing is not. So we can kind of say that DevOps is a collection of the kind of ideas that we use nowadays to create and deploy modern software. And with that comes usually your favorite part about DevOps, which is that not all of these best practices or philosophies work with all kinds of organizations.
Exactly.
So a lot of these come from the very big software development houses like Netflix or Amazon or Microsoft, where you're going to have tens of thousands of developers working on a huge amount of products. And of course, that doesn't really scale to a 3 people and the dog type of startup, right? So you want to talk about that a bit, as it's your favorite?
Yeah. Well, I've been working in lots of different kinds of projects, small ones, big ones, small clients, really big established kind of institutions. And there is always a way of doing things, and it's a different way for each company. But not I've never found a single way that would work in all those cases. And usually I'm not the one, of course, who decides what methodology we're going to use. It's already there. But mm, the more flexible the framework is, the easier it is to find the how should I say, it's the easier it is find the way that really works well with that particular case. Let's say if it's a bank or it's just a two-man show.
Yeah, I kind of
But with DevOps, the underlying the principles that why we do this is, let's say one of the core principles is that you don't do manually things, and that applies to all of those different kinds of projects, small ones and big ones, I would say.
Yeah, exactly. So the way that I present it usually is that when we're doing DevOps trainings, is that we kind of present this bag of tricks, but then it's up to you to decide which one of those actually fit into whatever it is that you're doing, and then maybe use one of those tricks, which is this experimentation oriented kind of feeling, so that you're ready to experiment with new things, and then you measure them, and then you see whether they made sense or not, right? So you can use some of the technologies with that come with DevOps just once and try it out, and then see whether it works or it doesn't. And don't kind of take everything as granted and then try to go somehow by the book. That's absolutely kind of against the principles themselves. But yeah, that's kind of yeah.
Larger organizations are usually very inflexible, so it takes time to learn a new trick. Let's put it that way. And
yeah, but it depends. It really depends, and that's kind of the nice thing about modern software development. A lot of these really high velocity environments push or high velocity requirements push these large organizations closer to the edge of DevOps. Let's say Netflix. Netflix is a huge company, a huge organization, and they're right there on the bleeding edge of DevOps because they have to be. It's kind of how they survive, right? So it's not necessarily the size, it's more of a kind of a philosophy, or maybe it's the age, right? The older an organization is, the more kind of technical debt and philosophy debt they have, and the harder it is to change the direction of what they do.
the thing is that if you have a way of working and it kind of works, then it's for those organizations it's hard to just change, because you already have a way of working that kind of works. And if you are very inflexible as an organization and maybe as people or person, then it's hard to change. But
Yeah.
when they do change, then hopefully rapidly they realize that, hey, okay, there is a new way or a better way of doing things. But the core of doing, for example, if you are creating software, you still have to write the software, and the core of writing the software, well, actually, that changes a little bit as well. You might be more testing oriented afterwards, because that increases quality and that actually speeds up things, even though it looks in the beginning that, hey, this is going to slow us down because we're writing tests, automated tests.
Yeah, so one thing that I just talked about is velocity. Let's see if we have a Wikipedia page on that. Velocity in software, yeah. So this is starting to be one of the most important metrics when thinking about how successful a software development department or actually even a software product department is. What's your idea with velocity?
I'm not sure what you mean by that question.
So
how
what
I
we're
see
doing
it?
with velocity is we're measuring how long it takes. Basically, we can do it in different ways, but like basically from an idea of creating a feature in a software to it actually being deployed in the production environment. That's velocity, right? So the more velocity we have, the quicker we can make this happen.
From my point of view, from my point of view, the velocity has never been as itself a very, very important metric. Maybe I'm lucky with the clients that I've been working with, that velocity is, it has never been a thing that we try to increase. We try to increase quality, for example.
Yeah.
But
exactly.
Yeah. So, but there are different kinds of organization. Maybe you really need to have a new feature in production in 2 weeks or 1 week or half a day. But I personally have been, maybe I've been lucky that I haven't been working with organizations where the velocity is the key thing. It's more about writing business logic that works without any bugs and things like that.
Yeah, exactly. So this is kind of, velocity is kind of what we're looking at specifically in startups, right? So if we're in a dynamic business situation, we have been seeing that usually the company or the service that comes out first with a new feature will get more traction, right? So
bigger market
quality
share
is kind of second
secondary.
Right?
Yeah.
Yeah, we need to get a feature out first to gain traction, and then we worry about quality later. So that's kind of usually the places where we are optimizing for velocity itself. And of course, velocity is something that we get through this kind of automation, right? So kind of through DevOps. And this is kind of, that's why I wanted to bring it up, because this is not clear for everyone. If you are in a, I don't know, a really important security backend system, then you don't care about velocity. You care about security and quality.
Yep, exactly.
Right. So very often when we're talking about these metrics, they as well depend on the organization that you're in. So you should pay attention to what it is that you want to optimize, and then just not blindly follow some best practices.
And
there are some other.
If you compare velocity from a company to a company, then maybe that metric is not even, you cannot compare the velocities. It's a bit difficult if you have a feature for one company that they need to get into production, then you have a different kind of a company with completely different software, and they need to get a different feature. Maybe the feature is named the same, but it's completely different. Maybe inside
we don't
easier
do cross comparison. No.
Yeah, it's easier within a company to measure the velocity and see if you're doing things faster or
yeah, and the actual number doesn't mean anything, but that's something that you want to optimize.
That's what I meant. Yeah.
Perfect. So there are other metrics here, especially with Dora. Dora is a DevOps Research Association, I think. Anyway, it used to be run by Google. Nowadays, it's its own independent organization that tries to research DevOps, and they have different kinds of metrics as well. So throughput, deployment frequency, lead time for changes, that kind of approximates the velocity in somehow. And then they also have stability. So mean time to recover and change failure rate, which are more kind of proxies for quality on the other hand. So that kind of idea of yours, that is actually part of the official DevOps research. But these are not perfect either, right? So already in this Wikipedia page, we can see that there is been a criticism about that. And it is a moving field. We don't know. We don't have absolute truths about this stuff yet. A little bit more about the background. So a lot of this comes from Agile as well. So we're kind of presuming when we're talking about DevOps that we are working with an Agile software development process. Other stuff that is related is the automation of the build process, as well as possible deployment into both testing and possibly production environments. So then we use what is called a CI/CD pipeline for that automation. Lean thinking as well. That's kind of this kind of continuous improvement idea that we're making small changes very often instead of these. My favorite example is Microsoft. Remember Microsoft Word back when it wasn't online yet? There was it was Word 97, and then came Word 98, right? They had like one version per year, which was already quite fast back then, right? So that was great. And then nowadays, like we deploy stuff on an almost daily basis. So we basically have a different version of Word available every single day.
But it's also in that case, when you say once per year, there was a reason for that as well. You first of all, different processes, but also the way software was distributed. You couldn't just send out new version to people every day. You didn't have internet, which you used to that you can use to download patches to your software. So that has changed as well.
Or then you did, right? So like Windows 95 was like well known for not being a complete piece of software at all. But then literally, once you have the CD and you have installed it, then the next thing you need to do is download everything again over the internet, so that you get an up-to-date operating system. Nowadays, we're maybe more used to that incremental.
Hey, I have a question.
Yeah, sorry.
About CI/CD pipelines. Do you remember? Because if someone is relatively new to this field, then and you're working with your clients or your organization, you have a CI/CD pipeline of sorts. But Johannes, you probably remember that we didn't have those at all in the early days. Everything was done manually.
Yes.
Literally every single time you install something into production, somebody built the software on their own computer manually, and then maybe the same person had permissions to upload this new version to the production server and install it. Everything manually.
Yeah. So
that's one of the reasons what we wanted to get away from. It was ridiculously complex and error prone.
I totally remember that. So first of all, we used Notepad or like Notepad++ to do the code editing, right? So no syntax checking, nothing like that. You had to write it correctly. No autocomplete, blah blah blah. Mm-hmm. And then we had the Java compiler. Talking about Java, because I guess that's what you're referring to here.
Yeah. In this case, yes.
The Java compiler didn't do recursive compilation over subdirectories. So in case you use packages, what we had was one batch file on Windows. that would go into each of the directories and then run the Java compiler.
I have forgotten all of that.
So whenever you created a new package, you actually had to go back to that batch
Yeah.
file and add it in so that that code would get compiled as well. So it was, yeah, horrible. And then compile times, like computers were still kind of working on steam back then. It's before electricity was actually invented, and it was like really slow to compile. So people came out with faster compilers. I remember the IBM Java compiler coming out. That would be a lot faster than the original Sun one. Let me see if I can remember. Was it was Jikes?
And one of the challenges was that if a person
Yeah.
does this, prepares a package for the production, and then next day someone else does that on their own computer, they might build
Yeah.
it differently, and that's one of the horrible things that you had.
Yeah. So kind of the problem was that of course that we would have some kind of a version control system in place.
Yes, at some point, but I remember starting and we didn't have any of those either.
Yeah. So then you would basically need to agree between developers what everybody would be working on.
Yeah.
And even if we would have a version control system, it would be a centralized version control system, right? Which is lock-based. So you're basically locking certain files, not allowing other developers to edit them while you are working on them. And then once you're done, you're unlocking them again. So this can start working. Very inefficient to work like that.
And error
prone.
And the CI/CD pipeline, and well, not magically. There's no magic in it, but it solves the manual part of things. But still you have to write the software, but the things and that's one of the things that, regardless of your organization, then you will nowadays need a CI/CD pipeline in order to have repeatable package, so that you can repeat the process of building and deploying something into production.
Exactly, to the point of like security, like so don't let anybody go into the production environment. Only allow the CI/CD pipeline to deploy it, right? So that nobody can go past the official kind of way. And then you can build security into the pipeline itself, therefore securing the production environment. But yeah, maybe going a little bit ahead of ourselves here, but yeah. So this, once we started to get proper build file support for Java with Ant and stuff originally, then things started to become a little bit more automated, and there would be less problems. So like in the beginning, literally when you would compile something, it would fail because of typos in the code, right? Because we didn't have an IDE, so there could be a typo, and you wouldn't know that until you actually try to compile it, and then it fails. You go and look at the code again, and so on. So we got a long way from that kind of environment. But the one thing that I also wanted to kind of, before we go deeper into these individual things, talk about is that it's actually not about tools that much. It's also about a philosophy or a culture, as saying in here. And kind of the key issue here is to take responsibility, full responsibility of the software, right? So traditionally, there would be this kind of handoff phase where developers would start off by developing some software and then testing it on their own machine, most likely, and then somehow handing it off to the operations people who would live in the basement and work on the production environments. And one of the things that was kind of interesting, because we happened to have been working with Java when it became a real backend language, right? So we would actually have Java software, and then we have ops people who don't know what to do with it. They're like, literally, so, okay, so you gave me this jar file. So what do I do? So how do I run it, right? And then that led to us, the developers, telling the operations people how they should do their job. And that's not a good idea, right? Because they are talking, they use certainly different tools to do things than what we do. And we literally run our tests in the foreground, and then they're supposed to, probably run it as a service somewhere. So that kind of brought a lot of trouble to the table. And then there would be this total lack of responsibility. Like the developers would be like, oh, we are not in the production environment. It's not our problem if things don't work over there. And then the operations people would be like, well, this is some Java thing. Well, I've never seen this before, so I don't know how it works. Right? It's the developers who should take care of that. And then basically, it's this hot potato that we're just throwing around, and nobody is accepting responsibility.
And if things didn't work, then it's always someone else's fault.
Exactly. And DevOps tries to change that by removing this barrier, by basically saying that if you write it, then you run it, right? So whatever you're writing, then it's your responsibility to actually run it in production as well. And this is now just one of those tricks that does, gives more responsibility to people. It gives higher quality, it gives better response times in case of errors. But again, you might have an organization where this is not possible, right? You might have I don't know, maybe you're running your stuff on a mini computer. You can't allow any developers into that environment, or there might be other considerations that stop that.
Or you're in a field which is highly regulated, like bank or some healthcare industry, and then sometimes you do have you cannot let the same people access production data, for example.
Yeah.
And if you are able to deploy something into production, it means that you probably could, or not probably, you could write a piece of software that downloads the production data.
Yeah.
And
Exactly.
that's not okay in every case. There are, domains where that shouldn't be done.
Yeah. But yeah, so that's kind of an example of basically a cultural or organizational change, which might be difficult to get through in a very old organization, but it's easy to start off with if you're in a new startup, because kind of there's no change required. We just do everything like this from day one.
And here I know from personal experience that this might be the cultural change might be the hard thing, not the technical details of starting to use a new tool or doing things a little bit differently from the technical point of view, but from the organization point of view, that the changing of ways of doing things might be the hard part. And that's interesting, because usually, well, in the past, you didn't change the way you do things. You just changed the tooling and changed those things. And that was the easy part.
Yeah, and it always had a limited effect on kind of just one person's job, right? So you didn't have to have this kind of cross-organizational change. So one of these cultural changes is microservices. Just maybe a quick intro into microservices, and then we'll handle this properly later. Like, what is the opposite of a microservice? Well, it is a monolith, and maybe a good example of a monolith would be Microsoft Word or Chrome, whatever browser it is that you're using. It's a single piece of software, and basically, whenever we deploy a new version of that software, the whole software gets deployed to you. So the individual modules that I'm sure exist within that software, they are tightly coupled to each other, right? So there is no kind of standard high-level API to talk between them. And there could be different kinds of patterns exist for that, but in general, we are dealing with the piece of software as one, and that of course brings problems to us. Just due to the size of that software, we need to run tests whenever a new version comes out, right? So we need to run the full suite of tests, even if we just make a single change somewhere. There's no way to only partially test a monolith, or could be, but traditionally it's not done. And that big piece of software might be so big that there is no single developer that knows every part of it. There might be this, secluded part of the software that people are kind of whispering about, and saying, don't go there. It's really difficult. Only John on the third floor knows how to work with that part. So nobody else is allowed to touch that. And that brings a lack of quality and a lack of velocity to the process. Right? Whenever you need to do a change where other modules are dependent on how your module works, in a big organization, you might need to send like a memo to all of the developers that, hey, we are going to change how this thing works. Please, everybody, make sure that your code is aware of that. And all of this slows down the kind of development process. So microservices are the opposite. So they're different parts of the software are totally independent, and they talk via a standardized API, often even an HTTP API or gRPC if you need more efficiency. And then we deploy the individual microservices, right? So if you're looking at the Amazon.com website or Netflix, there are thousands, tens of thousands of microservices that are producing that experience for you, and you don't see or know if one of those microservices has been updated, and they're constantly being updated. So that kind of gives more control to the developers of the individual microservices, and it speeds up the velocity, because now you only need to test the individual microservice. It's smaller, it's easier to deploy, so on. However, we're kind of masquerading the complexity of the system into these inter-microservice relationships that used to be easy to control because they were all a part of the same software, whereas now they're different, and they're talking HTTP to each other, and it's so much more difficult to figure out where things
you suddenly have a distributed system, and figuring out what happens in a distributed system is not trivial. You need to have
and even
tools for that.
replicating errors is difficult. So we are actually making, when we're moving, let's say if we would have the same system as a monolith versus a microservices-based architecture, I'm going to tell you that the microservices-based architecture is going to be more complex. It's like, and just kind of don't go there unless you need some of the benefits that come from microservices, like these kind of more velocity from the point of view of an individual microservice, individual scalability on a microservice level, or so on. So
that's actually that's a good principle of not changing things just because there's a new way of doing things, or a new architecture that you could try. You don't have to change your existing software if it works. But for example, if you need the scalability and your monolithic approach doesn't give you that, then maybe microservices is a solution for that, or maybe part of your application gets kind of converted into microservices, not your whole application, but just parts of it.
Yeah, and we kind of used to have this already earlier, right? So back in the days, we used to have a service-oriented architecture.
Yeah.
There, the services were kind of bigger than what the current microservices idea is. They're more like domains, kind of. So you could have, if you're an e-commerce store, you could have a service with regards to product stuff, and then a separate service with regards to I don't know, financials, right? Ordering and bank transfers and all of that. So the domain of each of the services was still quite huge, but it already kind of brought us into the world of distributed systems. Back then, we used really interesting stuff like RMI over IIOP, RMI over IIOP. So if you remember that remote method.
Remote method invocation. Yeah. It was really complicated.
Or C++, we used Corba for that. But yeah, so that's kind of the
that's actually a good reminder that there are different ways of doing things, and when we're talking about the monolith, then actually we had several monoliths working together. Maybe like that. So you don't have an organization that has one piece of software and everything is there, but you have lots of different kinds of larger software, individual pieces of software that they are working together. So it's not that
did we lose Mikko?
You understand what I mean? So you might because actually the way microservices is presented, I think I've been kind of seeing that for a very long time already, but still maybe the if you have a layered architecture, then the front part is the monolithic part, and then the back end is that it's already split into microservices, because with larger organizations you just have a ridiculous amount of software.
This is not black and white. So I always use clear examples exactly because of that. Something like Word, Microsoft Word, right? That's one piece of software, so it's a monolith. And then Amazon.com is tens of thousands of microservices, so it's microservices.
Yeah.
And then in reality, there are plenty of things that are in between.
Lots of things in between.
But it's more difficult. So I try to use the kind of naively the
Yeah. But hey, let's move on. We don't have that much time left.
No.
So
yeah,
that was
microservices. We're coming back to microservices later on, right?
Okay. Yeah, definitely.
So another kind of important cultural change that you already brought up previously is automation. And by automating, basically, we mean the whole CI/CD pipeline, including as much testing as possible. The reason why we want to do this automation is that it scales, right? So the more deployments we have, the more tests we need to run. So in an old way of doing software, you could have like manual tests, like you have a QA department that would literally click around in the software.
I remember that, yes.
Try to find bugs. But the problem is, of course, that doesn't scale if you start to like deploy every day, right? Because there is literally not enough time. So it starts to make sense to invest into automation of testing because you're getting so many repetitions of those tests. And then if you can test your software well enough, then you can allow your pipeline to deploy into production automatically. So if you have the possibility to run tests in such a way that you can trust the pipeline, that no faulty software can get through the pipeline because your tests will catch it, then suddenly deployment into production is no longer a special event, There are no fanfares going on anywhere in the office when you're deploying into production. It's just something that happens automatically on your behalf. And then we get into these really fast cycles that literally, if you just do a single change into the code space, you can immediately deploy that into the production environment. And that gives you that velocity that we've been talking about previously.
And repeatability. You don't have manual processes there. Even if someone else controls the CI/CD, the deployment part, which is that is one way of doing that. But even then, it is this one person is not manually deploying anything. It's just approving that yes, this package can be deployed, and then it gets deployed automatically.
Yeah, and in this,
the opposite of manually doing things.
Yeah, and in these tests, there can be so many things. Another thing that comes from this automation, of course, is that we are losing a little bit of visibility. Like in a traditional way, let's go a little bit forward from my Notepad days to the environment where we would even have like a CI server, like maybe a Jenkins server in the corner of the office. Like usually it was like an old desktop that was kind of moved to be the build server. So what would happen is that you would start a release build or integration build whenever you changed some code, and then it would run the tests, at least the unit tests for you. So what you would do as a developer is instead of kind of sitting there and waiting for it to work, is to kind of go over to the kitchen and maybe get a cup of coffee, talk to some other developers, and then whatever time later, how long your build normally takes, you go back to your desk and see the results. Let's say like 45 minutes later, right? Now, if I would come back 45 minutes later and the build server would still be running, I would know that something has gone wrong. It's not supposed to take that long. So I can start to investigate. I can start to look at, maybe I imported a new package by accident. Maybe if I create a container, I used a new base image that it needs to download, and it's huge, so it takes ages, or other things. And when we're using a CI/CD pipeline in the cloud, we don't see that anymore. Right? But we still have all of those metrics available to us from the systems, right? So all of these systems give you feedback into logs or into a metrics collector that you can then use to get back that visibility, right? So you have the build time. You don't need to know how much the build time is normally, but you want to see if it has dramatically changed from last time, right? If your build time now is double what it was the last time, then something has happened. Yeah, might be intentional, but might also be by accident, right? Or your build size, right? Previously, your build was 30 megabytes, and now it's 300 megabytes. Something has changed. If it's in the CI/CD pipeline, we don't see it. We never download that binary, so we can't see that it has changed. But the metrics will tell us that. So it's really important for us to kind of regain that visibility by setting up alarms with different kinds of metric system to kind of let us know that, hey, there's something weird going on now. And it might be that it's totally normal. Right? It might be I added a new thing there, so I know that this is okay. But it might also give us info that maybe a hacker has injected some unwanted, dependencies into our code, and now it's downloading half the internet and opening up vulnerabilities due to that.
Do you have anything else there on your mind? We're slightly running out of time here. I wanted to ask you about your future. What do you think? Yeah, what will happen in the future regarding DevOps? do you already know that, or do we know that something is going to change? And I know that things will change because it's
The
evolving.
only constant is change, right?
Yeah,
So DevOps is still new. We are still seeing how these different technologies work with different situations. So one interesting thing here is the state of DevOps report that comes from DORA. It tries to like listen to what the trends of the year have been, and what type of benefits people get from DevOps. So we're talking about maturity from a DevOps perspective, kind of telling you how many of the DevOps principles you use, and then how that affects your different kinds of metrics, like how quality gets affected by having an automated CI/CD pipeline and that kind of thing. And that's something that I suggest that people that are interested in this stuff start reading. So it's available for free online. You just need to register, if I remember correctly. Yeah, the state of DevOps report here. Read the report. Yeah, you just need to fill in your information, and then you can download it for free. And it's still moving at such a fast pace that it's really difficult to say what the future is going to be like. It's just going to be different.
but things do change. All the past, let's say, software development processes, there's always the new thing, and this is the correct way of doing things, or this is better than the previous one, and even then a new one emerges. But I think DevOps has brought a lot of things that will not change that soon, like the automation and thinking, the way of you think about the whole process. It's just not like a package, but it's a process of you putting something into the version control system, and then out goes something into the production. And the sequence of events, this used to be completely manual, and that has, I think we will not go back to the manual part unless something
No,
really special.
Again, I would say that this is not like a thing that has happened overnight. We just started to call things that we have done. We have done like software development previously. We have taken a look at different kinds of processes. What good parts are there? What bad parts are there? And that was why we started with XP and so on. So it's part of the same kind of trajectory. This has been going on for decades already, and now we just happen to call that DevOps nowadays. So it's just kind of a collection of best practices.
You might be already doing DevOps without realizing that you're doing DevOps.
You most likely are, yeah, right. But yeah, so as we can see, quite a lot to discuss on this topic, and we are of course happy to go deeper into any of the kind of subjects of the point. In case you happen to have a question or an idea of what you would like us to discuss, please let us know in the comments. We're happily taking suggestions, and we will be looking into most of the kind of technologies or best practices in DevOps in future episodes of this live stream. I would call that an episode. What about you, Mikko? You want to add something?
We agreed that we will not aim for an hour, but maybe more close to 45 minutes. Otherwise, we will just continue and continue. There are lots of.
Yeah.
This was supposed to be like a high level look into DevOps, not going into the details.
So let's call it an episode. If you're interested, we are teaching DevOps fairly often. We are currently investigating in creating a live online DevOps class which most likely is going to be available during the summer of 2024. If you're interested in being kind of a beta client for that, do let us know, and we will tell you once we get there. But yeah, that's it. Thanks a lot from me for taking part in this exercise of ours. Thanks, Mikko, again for asking a lot of good questions. And see you next week. Till then.
Bye-bye.
Bye.